Hello, am I audible? Can you hear me?
Sir.
Yeah, can you hear me?
Yes, sir.
All right, all right, all right. So did you do yesterday's like last class homework that I gave to you? Did you do this question? Yeah, yeah. Any answers? Do you have any answers?
No, sir.
Okay, I'll still keep this question as homework. Please try to do this. We'll be moving forward and we'll start with motion under gravity. We'll start with motion under gravity. Okay, so motion under gravity follows the same rules. Okay, just the difference is that acceleration becomes the acceleration due to gravity. That A becomes G. Acceleration in motion under gravity becomes G. G is the acceleration due to gravity, which is provided by the Earth, and that is the reason for the motion of the object. Okay, so all the equations are same, but that A becomes G. For example, if I write V is equals to U plus GT, it will be GT. V is equals to U plus gt, or s is equals to ut plus half gt square, or v square is equals to u square plus 2gh, which is the height which this is traveling. Okay, so that a becomes g here. This is what you have to focus upon. Rest everything is same. For example, let us start with the question. Basically, a ball thrown vertically upwards, okay, with a velocity of 19.6 meter per second from the top of a tower, returns to earth in 6 seconds. You have to find height of tower. So first I would like you to try this question. Every one of you try this question.
Okay, sir.
Hmm. Do anything. Do whatever you know. It doesn't matter that you're going in the correct direction or in the wrong direction. Just try to do, try to think. Then you'll correct yourself by my answer, and this is how you will like rectify it. So don't sit idle. Do anything. Please don't talk among yourselves. Any answers? I'll wait for 2 more minutes and then I'll start discussing the answer. Okay, okay. Now I shall solve it. Everyone
Sir,
focus on here.
we are going, sir. 2 more minutes, sir.
Okay, okay, okay. If you're solving, I'll wait for 2 more minutes.
Sir, sir,
Yeah, go on, go on.
133.8 meters, sir.
133.8 meters. No, that is not the answer. Okay, now I'm solving it. See here, everybody. Everybody look at here. I need silence, total silence, please. See here. The situation is that we have a tower here, okay, and from the top of a tower, the ball is thrown vertically upwards. So it goes something like this. It goes something like this. This is the trajectory of the ball. Okay. So the ball has been thrown upwards, and this is the height of the tower. This is the maximum height that has been achieved by the ball. Okay, and then after 6 seconds, the ball is returning to the ground. This is what is happening there. So what we will do, two ways are there. Either we can take the motion of the ball from here to the top and from the top to the bottom. This is one way. Another way, we can consider the motion of the ball throughout its length. How we can do that? So you just have to consider this equation S is equals to ut plus half gt square. So first of all, we'll be providing the direction. So let us provide the upward direction is positive and downward direction is negative. So you can take downward as positive also. That depends on you. All right. All
Yes,
right.
sir.
That depends on you. That depends on you. Now see here. S is equals to ut plus half gt square. Ut plus half gt square. Yes or no? Do you agree with this? Yes or no?
Yes, sir.
Hello. Am I audible?
Yes, sir.
All right. So in this case, you have to consider the initial velocity upwards. That is v. You are going upwards. The net displacement that is happening here is h minus h because that is happening downwards. So u into t, that is 6 seconds. U, that is 19.6 plus half into g is 9.8 into t is 6 seconds to be squared. Okay. One more thing, g is downwards. So that will be minus. G will be minus. All right. So this is how you have to solve this. This will be plus. So we consider the total net displacement from the like this surface or top surface of the tower to the bottom. Okay. And in all, we discussed it that this is minus h. This is minus h. That net displacement that has happened there is minus h, and that is u into t plus half into g into t square. Understood?
Yes, sir.
Solve it and find me the value of h from here.
Sir,
Yeah.
297.6, sir.
How much?
297.6.
No, no.
Sir, the
297.6.
value of G.
Value of g is minus 9.8.
Sir, we took G as 9, 10, sir.
No problem. Even with that, no problem. See here. That is too big answer. See here. Minus h is equals to 19.6 into 6 minus half into 9.8 into 6 square. So h will be equals to minus 19.6 into 6 plus half into 9.8 into 6 square. That will be this will be 117.6 plus this is minus, and this part will be 176.4. So if you solve this, you'll get 58.8 meters. Check it once. This is the answer that you should get. Check it once. You must be having calculation error,
Yes, sir.
right? Right. Let us move on to the next question.
Sir, 2 minutes for copies.
Yeah, do it fast. Do it fast. Is it done?
I have doubts, sir. Sir,
Yeah.
I have doubts, sir. The value
Yeah,
of
go on.
U, the value of U is 19.6 or this 19, sir? The question.
19.6, 19.6 in the question. See there, the question. Question, it is 19.6 meter per second.
Oh, okay, sir. Completed, sir.
Completed?
Yes, sir.
All right. Now see there. Next question says that. Next question says that. Okay. A food packet. A food packet is released from helicopter. Is released from a helicopter. Released from a helicopter, which is rising steadily at. Which is rising steadily as steadily at 2 meter per second. 2 meter per second. So to find one after 2 seconds, after 2 seconds, what will be the velocity? What will be the velocity after 2 seconds of the packet? This is first part. The second part says that, okay, how far it is below after 2 seconds only. How far is it
Sir,
below? Yeah.
sir, can you
Any doubt?
explain the question, sir, from first?
Yeah, yeah. Just let me write, then I'll explain it again. How far is
Sir,
it
your
below
hand is. Yes.
from the helicopter? 1 minute. See here. A food packet is released from a helicopter which is rising steadily at 2 meter per second. So the helicopter was there. It was rising steadily at a rate of 2 meter per second, like from the ground towards the sky. So you have to answer two questions. Two sub questions are there. After 2 seconds, what will be the velocity of the packet? First sub question is what after 2 seconds, what will be the velocity of the packet after release? Second question, after 2 seconds only, how far is it below the helicopter? Okay. So let us say that helicopter was there, it was riding steadily, it was rising steadily from the ground. All right. And after 2 seconds, since it was rising with 2 meter per second, he dropped a packet. The packet will go like this. It dropped a packet. So what will happen? I'm just giving you a hint. The initial velocity of the packet will be initial velocity of the helicopter. The packet will go like this. So after 2 seconds, it may be somewhere here, whatever it be. So after 2 seconds, how much it is below the helicopter and what is the velocity of that particular packet that you have to find. Try to solve this.
Sir,
Yeah, any doubt?
sir, right little bit bigger, sir.
Pardon?
Right little bit bigger, sir.
Oh, I'm sorry. Actually, this is the pad that I'm using that is quite small. Okay, I'll try to. Is there anything I need to repeat? I'll write it bigger from the next time. Shall I repeat the question?
Yes, sir.
Okay, a food packet is released from a helicopter which is rising steadily at 2 meter per second. A food packet is released from a helicopter which is rising steadily at a rate of 2 meter per second. First sub question is that after 2 seconds, what will be the velocity of the packet? And second part, after 2 seconds, how far is it below the helicopter?
Sir,
Yeah,
the question is not visible.
I'm repeating it right
Can
from
you
there. I'm repeating it. Write it there. I'll try to write
get
bigger
the
from the
net
next
on
time.
the screen, sir?
Pardon?
Sir, can you zoom your screen, sir?
Actually, it is from the Zoom now, so they don't allow it to zoom. Totally show that screen. 1 minute. See, I'm speaking it again. Please write it down. A food packet is released from a helicopter which is rising steadily at 2 meter per second. A food packet is released from a helicopter which is rising steadily at 2 meter per second. First subpart is after 2 seconds, what will be the velocity of the packet? What will be the velocity of the packet? Second subpart is how far is it below the helicopter? How far is the packet below the helicopter? Now is it fine?
Sir,
Yeah,
sir, for first question, 21.6 meter per second. So,
21.6 meter. Let me think. No, that is not the answer. You should provide the vectors correctly. Provide the vectors correctly. understand the situation, like provide the diagram, and then provide the vectors.
Sir, 19.6 meter per second.
No. See, I'll answer the first part. First part says that, see, the condition is like that. The helicopter is there. I'm drawing it again, or I'm showing it here only. Helicopter is there, which is rising at a speed of 2 meter per second. That is at upwards. Let us consider the upward direction positive and the downward direction as negative. Okay. So the draw, like the parcel, wherever it would be below the helicopter, and it will be going down. The velocity will be downward. So velocity of the parcel v that we don't know is u minus of gt, because g is acting downwards, u is acting upwards. Okay, because initial velocity of that particular particle will be the same as that of the helicopter. Are you getting a point? Whatever the velocity of the helicopter will be there, that velocity will be transferred to the packet initially. So initial velocity of the packet is 2 meter per second upward. After time t, it will be minus 9.8 times, and that is after 2 seconds. So it will be 17 minus 17.6 meter per second. Minus means with this velocity, it is going downwards. Next one you find.
Sir, sir,
Yeah, any answers?
sir, it is dropped from. So, sir, it is dropped, no, sir. So, how it is minus g?
See, g is acting downwards only, na? G is acceleration due to gravity. Where is it acting? It is acting downwards. And for downward, whatever is downward, we are considering it to be negative.
Then how it is negative, sir? It is attracting towards gravity also.
Yeah, see, basically what we did, it depends on you. It depends on you, like what you are doing. If you understand it here, that we will be considering, it depends on me. If I am considering the upward, whatever is there going upward, in the direction upward is positive, and whatever is in the direction downward is negative. So where G is acting for everything, whatever is there on the earth, G is acting downwards. Okay, that if the parcel is here, on this parcel, the g is acting downwards. That's why I'll be considering g as negative. Even if the body is going upward, even if the body, like, even if we apply the same formula for helicopter, which is going upwards, for that we'll be considering g downwards and negative only. But if you consider g as positive, the downward direction as positive, then you will have to consider the upward motion as negative and downward as positive. So in that case, g will be positive. Got it?
Yes, sir. Sir, for second question, 78.4 meters, sir.
78.4 meters. No. Think again. I'll answer this. Everybody try to solve it. Any answers? Okay, see here. Now I'm solving it. See here. Let us say that this is the helicopter. This is the helicopter. And at this particular instant, it dropped the parcel. So parcel, what will parcel do? Parcel will go like this, somewhat like this, and it will fall down because initially it will be having the velocity as that of helicopter. So let us say after 2 seconds, parcel will be somewhere here from the helicopter. So this is height h. So height h velocity initial height h is equals to ut plus half gt square, right? Height h is negative downwards, initial velocity upwards positive, g negative downward. Okay. Now tell me what will it be? What will be the height h? Calculate it from here. Initial velocity is with the helicopter, that is 2 meter per second. Time taken is 2 seconds. G 9.8, time again is 2 seconds. G is negative because it is acting downward. U is positive acting upward. Height going down negative. Find height from here. Tell me the value of height.
Sir, minus 98 or so.
Minus
98.
98. How are you solving this? Height is minus u into t plus half gt square. If you take the minus on the other side. So u is what? Minus 2 into 2 plus half into 9.8 into 2 square. You'll get 15.6. Are you getting 98 meters? You'll get 15.6 meters. Isn't it? Check it out. Isn't it? Are you getting this? Say yes or no. Everyone getting this? But this is not the complete answer. This is not the complete answer. In 2 seconds, the packet fell down. But in the same 2 seconds, the helicopter will also go up because it is still rising. In the same 2 seconds, after dropping the packet, the helicopter will also go up. Okay, so that will be h dash. What will be h dash be? H dash will be the velocity of the helicopter into time. So that is 4 meters. So from the point of projection of that particular particle, the packet fell down. It was the point of projection. The packet fell down by 15.6 meters and the helicopter went up by 4 meters. So helicopter is here now. How far it is from the helicopter? So that will be 19.6 meters. That is the answer. Tell me, did you understand it or not? Say yes or no. Put a thumbs up if you understood.
Yes, sir.
All right. With the same 2 seconds, the helicopter will also go up, and that's why what will happen? The distance will increase, and that's all. That is also you have to consider. These questions come in exams. Write it down.
Sir, completed, sir.
Okay. I'm giving you the next question. 1 minute. Can you see this question? Tell me, can you
Yes,
see this question? All right. Write it down and try to solve this. Any answers? These are really good questions that has been previously asked in the exams. And these questions will make up your mind so that you can solve more different kinds of and wide varieties of questions. The more questions you have to solve by yourself. I just try to make you solve different kinds of questions, and you have to solve more such questions so that you get practice of it. Only solving one question will not do. Shall I start solving or you're doing it? Okay, I'll wait for 2 more minutes. Shall I start solving it?
Can you solve?
Yeah, right. Okay. So the question says that we have a parachutist that bails out from an aeroplane, and after dropping through a distance of 40 meters, he opens his parachute, right? After dropping through 120 meters, he opens his parachute and deaccelerates at 2 meter per second square. If he reaches the ground with a speed of 2 meter per second, how long was he in the air? At what height did he bail out from the plane? Okay, now let's see the question. So we have initial velocity. This was the plane. Okay, let us say this was the plane, and he bails out from here. If it is bailing out from here and the plane is going horizontally, so he has no initial velocity in downward direction. He may have initial velocity in the rightward direction, but if we are considering the height, so that is a vertical motion, so he has no initial velocity in this direction. No velocity that affected its height. All right. He may have certainly bailed out reached to the point on the ground somewhere here, not exactly below the where he bailed out basically, because he was having a kind of horizontal velocity that was with the plane. So he'll be covering this trajectory instead of going vertically down. Okay, one thing. Next thing, um, we what we need to see. Let us see that here before reaching the ground, he must be having a velocity v. So we can use this formula: v square is equals to u square plus 2gh. 2 minus of g, because that is acting downward. We'll be considering the upward direction as positive. Or let us consider the downward as positive now. Upward negative, downward positive. So it will be positive only. 2g and h is also in the downward side, so it is also positive. All right. So u is 0, 2gh. So v square. So in order to calculate the height, we need to calculate the velocity, or simultaneously, if you want to calculate the velocity, we need the height, right? Second equation. Um, or other way, we can use s is equals to ut plus half at square, half gt square. We are considering the downward direction is positive, so h is plus s is plus h, u is 0 plus half into g, that is 9.8, and t square that we don't know. All right. Um, we don't need to go through this. We can directly solve this out. We can directly solve this out. See here. So v is equals to u plus gt, everything in the downward direction. U is 0, g is 9.8, t is how much? T we don't know, right? Now the h height that has been covered is 40, is half into 9.8 into t square. So from here t will be what? So 2 into 40 by 9.8. You solve this, you get t from here. You put the t here, you'll get the velocity from here. So this is the velocity that you'll get when you'll be reaching the bottom. Are you getting my point? Are you getting my point? Yes or no? Tell me this time value and tell me this velocity value while putting the values. Tell me, do it fast. What was the time that you get? Tell me the time. What time value did you get? Try to solve this. First of all, tell me, did you understand this part? Yes or no? Please, anybody tell me, did you understand this part? Yes or no?
Yes, sir.
All right. So tell me the time. Just put the values here and tell me the time. Then take that time and put it here. You'll get the velocity. Second part. Now we have to move on to the third part. But do it fast.
So time is equal to root 2.85.
Root under 2.89. No, it will just be 2.89. It will just be 2.89 seconds. 2.86 seconds. If you calculate this totally. Okay. Now velocity. Velocity is what? 9.8 into 2.86. Tell me this value. Tell me this value. Multiply fastly. You have to do the calculations as fast as you can. It will be nearly 28 meter per second. Check it out. So this was the first part. Now what happens after bailing out?
27.26.
Yeah, nearly 28 meter per second. After bailing out, like after he opened his parachute. So after he opened his parachute, what happened? His initial velocity was 28 meter per second. This was till he was opening the parachute. Okay, till he was opening the parachute, that was the velocity. So at this, after reaching this velocity, he opened his parachute. So we'll be considering that motion initially to be 28 meter per second. Acceleration was given 2 meter per second square. Sorry, downward. So, okay, downward positive 2 meter per second square, and velocity. Okay, so final velocity while reaching the ground is 2 meter per second. That has been given in the question. So can we calculate the time to reach the ground? So that will be v minus u upon a. That is the time to reach the ground. So 2 minus 28 upon 2. Isn't it? Okay, the acceleration will be negative because that acceleration was upwards. Parachutes provides acceleration upwards and G provides acceleration downwards. This is what the parachute do. So that will be minus 2. So this will be minus 26 by minus 2. That is it is plus 13 seconds. It will take 13 seconds to slowly come down after opening the parachute, right? So now what is the distance traveled? That will be u into t plus half into g into t square. U into t plus half into g into t square. What is u now? U is 28 into 13. Okay. And then minus half into 9.8 into 13 square. 9.8 into 13 square. Tell me this value. This was the distance traveled during the parachute, during he was attaining with the height of parachute. This was the distance, this distance 40 meter was traveled before parachute. So this total height covered 40 meters before parachute, and this is what we are calculating after parachute. Tell me this value. Tell me this value, solve it fast. This is nearly 195 meters. You solved too slow. This is nearly 195 meters. So total height was 195 plus 40. And what was the total time? Total time, it took 2.86 seconds before parachute plus 13 seconds after parachute. So it was 235 meters total height it traveled, and total time was 15.86 seconds. Did you understand it or not? Or shall I repeat it again? Tell me. Did you understand it or not? First, we calculated for the portion before opening of parachute, and then we calculated for the portion after. Pardon?
The last two steps on this one, explain, sir.
Last two steps. These two.
No, sir. Before that, sir. Yes,
Okay.
is equal to
Before that, what we did, S was the distance that he had traveled after opening of parachute. And at that time, he had attained an initial velocity of 28 meters per second by falling under gravity. And after opening parachute, the parachute was providing a deceleration of -2 meter per second square. And after reaching the ground, he had a velocity of 2 meter per second. So what was the time of descent with the parachute? That was 13 meters, 13 seconds. And that we put in S is equals to ut plus half at square. Initial velocity after opening the parachute was 28 meter per second, and time is 13 seconds of the parachute. So we calculated the total distance traveled while opening of parachute, that is 195 meters. Understood? And we added with the initial parachute. Understood or not?
yes, sir.
So this distance we added with the distance that he had traveled without parachute. So total distance was this plus this, that is 235. Total time was 2.8 plus 30. Is it done? Is it done? Tell me.
Yes, sir. Yes, sir. Continue.
All right. That's all for today. Try to solve the homework. That is most important. You're not solving homeworks, and solve more questions. These questions will not do. We are just practicing the different types of questions. You need to practice more of such kind. All right, we'll be meeting in the next class. Please make your doubts. Bye then.